Hi guys, your goal today is to get the note sheet from the sub. The sub should have passed it out by now. You're going to fill in the note sheet as you watch this video. You need to pause when you are writing down definitions or if I'm going too fast. Pause, write things down, and then write down any questions that might pop up while you're listening and watching on the side, and I will answer them tomorrow. After that, you need to grab the worksheet. Finish the worksheet by the end of the hour and turn it in, please. I hope you have a great day, and I look forward to seeing you guys tomorrow. All right, the learning target for today is I can connect the p-value to significant results and draw conclusions about my data. So, what is this p-value? We get it. So what? What does this tell us about our suspicions? We started off with a null and an alternative hypothesis. A reminder, your null was what should happen. Your alternative hypothesis was what your suspicions were about. Well, we get a p-value then. So once we did our null and our alternative hypothesis, we gathered evidence. Let me move this back up. We had a normal curve. We had our p. We had our standard deviation. We had our p-hat. We got a z-score. And we got a p-value. What does that p-value mean? Well, in context, what it means, and now you need to pause this and write down this definition. The p-value is the probability of getting a statistic as extreme or more extreme than what we calculated, given the null hypothesis is true. So what does that mean? Here's my statistic. When we get a p-value, it's the probability of this statistic happening, or greater than that, more extreme than that, given this null hypothesis right here is actually what should happen. All right, I'll say it one more time. The p-value is the probability of getting a statistic, that p-hat, as extreme or more extreme, so right here, than what we calculated. So whatever that p-hat was that we calculated, given our assumption is true, the null hypothesis. What should happen is true. Well, what does this probability tell us? So we know how to interpret it. Be really careful. You only need to write this statement, the interpretation of the statement, when you see the word interpret the p-value. Please make sure that it is in context. What do I mean by context? I don't want the null hypothesis is true. I want you to actually write in words what the null hypothesis is. So what does that mean? Well, for example, in our basketball example, what should have happened is given the probability that given that the percentage of basketball free throws that he made is 80%. The smoking one, given that the percentage of teens that haven't smoked is 50%. Whatever that null hypothesis is. So this p-value, well, what is that probability telling us? Listen first and then pause and write down. This is telling us if we have significant results or not. We have an alpha, which is stating our cutoff p-value for a statistic to be statistically significant. Okay, what did I just say there? We have an alpha. You will be given an alpha. An alpha looks like this. And it's a certain number. And it's going to tell us our cutoff for a p-value. So we're going to look at that p-value and we're going to compare it to what that alpha is. And we're going to say, did it make the cut? And if it did make the cut, that means our results are statistically significant. So in a nutshell, if the p-value is smaller than the alpha, we say that the data is statistically significant. Pause it right now, write it down, and if you're feeling a little overwhelmed, don't worry, we will practice it in a couple problems. Okay, so now we know, do we have significant, we know if we have significant results or not. Okay, so then what? We need to draw a formal conclusion. And there's one of two options dependent if you have significant results. Now you're probably wondering, well, what is alpha going to be? On the side, let's just write down some common alphas. I will give you alphas. The most common alpha is 0.05. But in the medical community, often they use 0.01. And then once in a while, you'll see a p-value that's 0.10. And we'll talk about this in our two examples that we do together. So what's happening here? Let me just restate as you're watching. We have a null hypothesis and an alternative hypothesis. We get our data, we have our p-value. We look at our p-value now compared to alpha, and we decide if we have significant results. Well, let me give you a formal way to decide if we have significant results, okay? One of two options dependent if you have significant results. The first option will be the p-value is less than alpha. If your p-value is less than alpha, we have significant results. So we analyze here. We need to compare our p-value to our alpha. And when we do, we need to write a formal conclusion using statistical language. The conclusion statement, which you'll be asked in your homework, you follow it just like this. Because our p-value is equal to blank, you fill in whatever that p-value is right here. Okay, which is less than whatever the alpha is set at, and I will give you what that alpha is set at. We reject H naught. We have evidence for HA, and I'm going to circle HA or underline it because I want HA in context. That means tell me what HA is. What's the situation? Pause it if you need to, and we're going to go through the other option that might happen. Okay, so if we have significant results over here, we don't have significant results over here, and this is when the p-value is greater than our alpha. And here's how we write our statement. Because our p-value is equal to whatever that p-value is that you calculated, right? Which is greater than alpha is equal to whatever that number. And alpha is just that Greek symbol meaning alpha. We don't have to write out alpha. We fail to reject H naught. We have no evidence for HA. And I do want you to write HA again in context. What is the situation of HA? HA is your suspicion. What was your suspicion? All right, let's practice this now in an actual example that we've been working on in class. Okay, so some of that you're maybe thinking, huh? Let's practice it in an actual example and hopefully it will make more sense to you. I'll walk you through step by step on how to write a conclusion. We're connecting our p-value to significant results, so we compare it to our alpha, and then we draw a conclusion using statistical language. A basketball player claims to make 80% of his free throws. However, at one practice, he only made 32 of 50 shots. Is this evidence that he makes less than 80%? So yesterday we went through the state part and the do part. I want to just talk about the state. Yesterday we said, hey, well, what should happen? Our null hypothesis. What should happen is the claim. He's claiming 80% of his free throws he's going to make. But the suspicion is he makes less than that. And some of you, again, remember we're having trouble. Well, wait, what's a less than versus a greater than? Just a friendly reminder that this less than, you could almost argue that it looks like an L. So P is L, less than 0.80. And what is P? Well, you're supposed to write P in words, and I don't have room here, and we already did it in our notes, but it's the situation. P is equal to the percentage of free throw shots this guy made. All right, well, we went through, we did the do part. We stated our sampling distribution. We found our statistic, 32 out of 50. We found our z-score, and then finally we found a p-value. And this is our p-value, 0.0038. So now we have our p-value and we have to say, well, are our results significant? And to find out if our results are significant, we have to examine it compared to alpha. Now, if I don't give you an alpha, you always assume it's 0.05. We've been talking about our 5% cutoff all year. And I usually will give you an alpha like I do here. So are our results significant at alpha equals 0.05? That means, is our p-value less than alpha? And what we say then is we say yes, because our p-value is lower than alpha or less than alpha. So this is the first question that will be asked today on the front page of your worksheets. You're going to look at a given p-value, or you need to find the p-value based off of a given z-score. So I'll give you the z-score. You don't have to do any computing. You just find the p-value. We compare our p-value to alpha and we say, yes, we have statistically significant evidence. Then we need to draw a conclusion. Well, because our p-value is lower than alpha, we're going to use this conclusion over here, okay? And this is how we state it formally. Because our p-value is 0.0038, which is less than, oops, alpha equal to 0.05, we reject our null hypothesis. We have evidence that the percentage of shots the basketball player made is less than 0.80. So all I did right here is I took this sentence and I filled things in. Because our p-value was equal to 0.0038, which is less than alpha equal to 0.05, we reject the null hypothesis. We have evidence for, and I put HA in context. So it's helpful to think about HA at the very beginning. What was our HA? Our HA was we were suspicious that this player's free throw percentage was less than 80%. And I just wrote that out in words. That's our formal conclusion. That's one thing I'm going to ask you to do today. Now on the front side of the worksheet, I don't have it in context. You're just going to be given a z-score. Here's an example. You may be given a z-score of 2.5. You need to find a p-value. Now, because this z-score is on the positive values, you still have to subtract from 1, whatever that p-value is. And then when you're concluding, you don't need it in context because I don't give you any context. And I'll have the key on the table so you can check what I mean by that. All right, and then lastly, I'm going to ask you to interpret that p-value and interpret it in context. This is the probability of getting a test statistic as extreme or more extreme than what we calculated, given the basketball player's shooting percentage was 0.80. Again, given the null hypothesis is true, this is what should happen right here. What should happen is the basketball player shooting percentage was 80%. So the p-value is the probability of getting our statistic, that 32 out of 50, given this is true. I literally just took in my p-value interpretation right here, and I filled in the null hypothesis. All right, let's try one more together. And again, I hope you're pausing where you need to, because I'm not always spending the time. You guys are in the classroom. I'm just kind of trying to get through it for you guys. And you may want to pause here and fill some things out if you don't have it, and then move on to the next example. So I'm going to move on right now and finish up these notes. All right, according to the Center for Disease and Control, this is the one we talked about yesterday as well. 50% of high school students have never smoked a cigarette. Tasha wonders whether this is true in her large high school. She surveys 150 students and 90 say they have never smoked a cigarette. What should she conclude? Again, let's just remind ourselves, what was this null hypothesis? The null hypothesis was the assumption, the given truth as it is right now is 50%. Tasha is suspicious it's not that. There's no keywords. So we know it's not equal to. The keywords would be greater than or less than, some sort of form of those. Well, what did we do from there? We wrote our null, we wrote our alternative, and we wrote P in context. We then went through and we did our do step. We drew our curve. We stated our center. We stated our standard deviation. We found our statistic. We calculated a z-score and we calculated a p-value. And the important thing was from yesterday was we had to multiply that p-value by 2 because of this not equals here. When we did that, we got a final p-value of 0.0124. Well, what does that mean? We need to say, are these results significant? So we have to compare it to alpha. And the alpha I give you here is 0.10. And then we say, okay, well, what is it? Our p-value compared to alpha, and our p-value is greater than alpha here. 0.0124, I'm sorry, it's not greater than, is less than alpha. So what does that mean? All right, so what we just said, and I made a little mistake there, I'm sorry. We compared our p-value to 0.10, and it's less than alpha. So again, we say, yeah, we have significant results here. There's something to this. What does that mean? We have evidence for our HA. Well, let's write it formally. How do we conclude this? We say, well, because our p-value is 0.0124, which is less than alpha equal to 0.10, we reject our null hypothesis. We have evidence that the percentage of teens who haven't smoked is not 50%. Now, unfortunately, we don't know if it's bigger than that or smaller than that. We just have evidence right now that it's not that. You think about this stuff, you guys, this is like court of law. We come, we give a statement, we present our evidence, and then the jury makes the decision. Was there enough evidence to say, yes, they are guilty, or was there not enough evidence to say that? And that's what we're doing. Now, if you keep listening right now, I'm going to show the p-value up here, and then I'm going to start worksheet 1 with you for those of you who might need a little extra help. So do that now, but let's talk about that p-value here. Oops, I just need to extend the page. If we're going to interpret the p-value, we're going to say this is the probability, and I'll write it down. Of getting a statistic as extreme or more extreme than what we calculated given the null hypothesis was true. Well, what's the null hypothesis? The null hypothesis is what should have happened. The percentage of teens who haven't smoked is 50%. All right, for those of you who are still listening, you want to grab your worksheet right now and just pause it and then come back and I'll start the first one with you just to get you guys going.